Think. Always practice. Hello everyone, I'm Kay. Today I'm bringing you a tutorial on a carbon fiber fabric joint. This tutorial's mainly designed to help everyone get familiar with the joints we're using. What exactly do these parameters mean, and which parameters can be combined? What kinds of graphical changes can they create? This is essentially a tutorial about tools. So everyone should really make sure to master these tool-based tutorials. That way, in the future, you can flexibly apply them in more of our art-related tutorials. This will reduce the communication barriers between you and me. That way, everyone can spend more time focusing on expression. You can appreciate the beauty of these materials instead of getting caught up in the parameters. But I still hope that at the very beginning, everyone takes the time to really understand them. What are the parameters of these things, and how exactly should these nodes be used, and what kinds of changes will different combinations produce? First, you can check out the bottom of the video for this node. There you'll find an overview of our entire production process. I've already posted it. I've made some videos to explain things for everyone, so make sure you check them out. As for this whole node, I've divided it into several categories, which are called 111, 121, 1314. Right? So what is this one? It's an element, right? It's our element. 1, 2, 3, 4, divided into 4 small elements plus 1, 5, the 5th element. Then here, there are some simple merges where we simply combine these elements. After merging, we make some simple adjustments and then merge them again. Once more, we merge it again. After the second time, we output these images that we use for our next generation work. The overall framework structure is like this. As for this area above, since the next generation colors have some black and white gradients, we also applied some black and white gradient texture processing here. We made some separate adjustments to its color, and that's basically the whole framework. Next, we'll start from the first node and give everyone a brief introduction to some of the nodes. Actually, I've also introduced this in other videos, but you can also go to my collection to find my previous videos. Some of them are about how to create nodes. We can just start by looking at our first leather material. First, we created a gritty and linear, which means our table, Grea our gritty and linear 2. Then, if what you create is horizontal, there's a rotation angle here. If we rotate it 90 degrees, it'll be the same as mine. So what is this used as the foundation for? Let's first talk about our first element. As for the first element, first we use transform 2D and hold down the shift key, right? Rotate it 90 degrees and then give it a blur. The value is set very high to make it even more blurred. Then we add a level to adjust its maximum value. We do some cropping of the minimum value so that the whole look becomes a bit grayer. Then we bring in a shape. By entering the shape command, we can bring up a sphere. For the sphere, we use a variable width ellipse, actually a perfect circle with variable width. Then we apply a transform, which basically moves our object downward and squeezes it inward, forming 2 semicircles that are tangent at the top and bottom. Pay attention here. Our offset is set to negative 0.5 on the y-axis. That way, it moves 0.5 pixels down along the y-axis. This is the y-axis, this is the x-axis, so the center of our circle lines up perfectly here. Then we add a blur to it. Next, we subtract these 2 images from each other. You can see if we subtract a lot, this part gets cut off, right? If we subtract just a little, it only trims a tiny bit, leaving it slightly blurred. The purpose of trimming just a little is to make it easier for the start of this part to have a bit of an inset feel, because what we're doing is, such a carbon fiber cannot be inserted in a straight line. It will definitely have a slight curve. So we'll roughly trim a bit here. Then we'll use our tile generator, which is an old friend of ours. We've talked about this many times. Here, I'll briefly go over the parameters for you. Here we have XO 16, Y 8. There's something I want to discuss. When you increase the y-axis height, it actually affects the scaling of elements along the y-axis, right? Including the x-axis, increasing the height also affects the scaling of x-axis elements within the entire image. It's not just the scaling shown below, right? The top shows the scaling for each individual element, but the number affects how many x-axis elements you have in the overall image, right? The more elements you have, the flatter each individual element will be. Everyone needs to pay attention to this. Regarding our parameter conditions, the x-axis and y-axis are respectively 8 and 16. Then below, I basically didn't change anything. There's one thing, our offset. If you don't change it, it's a series of 1-to-1 white elements overlapping each other. Changing the offset by 0.5 will shift it along the y-axis by 0.5 units, creating a staggered effect. Okay, here we also have a check mask. What is a check mask? It's a checkerboard-like mask. It will adjust the elements. For example, if I change my offset and check mask is checked, they should be arranged one by one. But if you turn off the checkerboard, the first one will be visible, the second will be dark, the third will be visible, and the fourth will be dark, creating a checkerboard pattern. Combined with our offset, we can achieve the shape we have now. Other than that, I didn't make any major adjustments, including the brightness and randomness. Okay, then here we use a commonly used tool called Hasgram scan, which I won't go into too much detail about. It's used to extract our black and white data. Then we use Transform 2D to place it horizontally. Note that I moved it slightly upwards, about 0.125 units. 0.125 is actually 1%, right? Since our y-axis has 8 units, moving it by 1% is divisible. So we moved it upwards by 1% to create a staggered overlay effect when these two images are combined. So here we show you that we've used max lighten for this staggered overlay. What does max lighten mean? I've explained it before, but here's a review. Max lighten is the blending mode that selects the higher value between the foreground and background. In other words, when we merge the foreground and background, the higher values will be displayed and the darker values will be hidden. What are higher values? They are the higher values of the foreground compared to the background. This is a very good blending method, and it is very commonly used. Please remember this. Now we have provided KS-gram scan, and these two files are ready. That is, element 1 is ready. Next, I will talk about element 2. For element 2, we still use a tier generator. This tier generator is the same as the tile generator above, but with more adjustable parameters. Here we are using a y-axis scaling of 50 over 50, over 10, right? 50 over 10. Here we have performed some scaling processing on the x-axis and y-axis of individual elements, right? You can see that we have increased this value a bit. Adjusting this value will change its scaling, and the random parameter is basically the random scaling for the x-axis as well as the random scaling for the y-axis, both set to 0.4. The overall scale is 1. The offset is also set to 0.47, so it's slightly staggered along the y-axis, shifting each row down a bit to create that uneven, irregular look, which is easy to understand. Here, we've also added a bit of position randomness, like randomizing the x-axis and y-axis positions to make it look even more chaotic. No rotation was added. We also used a luminance radar here, which is basically randomizing the brightness. If you don't use it, you can see all the elements have the same brightness. But with luminance radar, you get that interlaced black and white effect, which is exactly what we want. The rest of the parameters weren't changed much. Then here, we added a directional warp with a diagonal direction blur. It's basically a mirrored blur. Here, we've set it to blur along our skewed axis at 90 degrees with an intensity of 10. You can see that the higher the value, the blurrier it gets. It feels more like a kind of anisotropy, but compared to regular anisotropy, its precision is higher. So we've used this method to replace the anisotropy noise we learned earlier. You can clearly see that its overall smoothness is higher than before. It's basically a more advanced form of anisotropy. You can remember this as an upgraded anisotropy effect. Then, for the warp, we use a general modification series which connects to our fourth element, a Gaussian scan, a kind of Gaussian effect. Then, here's something you should note. We see our material is 256 by 256, right? We changed one of the material's inputs to 256 by 256 in the top left corner. Why is that? Because if a texture is smaller, it will become more blurry when enlarged. In other words, if we want to blur a texture, instead of using 2 nodes, we can simply shrink the texture. So 26 by 256 is now Jason's shrinking node. We'll use this node as an input node for our warp, the gradient. As you can see from the input node, we can control its distortion, preventing it from being completely flat. A slight distortion makes it appear more natural. Here we have Transform 2D, which essentially rotates it by 90 degrees. We also divide it by 2, which doubles the tiling value. Multiplying by 2 effectively halves the tiling value, scaling its 4-dimensional continuity. This makes the element appear noticeably smaller. Then we apply a Sith transform, setting its rotation to -25%. Next, we combine the backquote save transform with the previous backquote transform using a directional warp. We've discussed this node before. You can refer to a previous video. Here, I'll mainly focus on the values. You can see the warp angle is upward and the intensity is set to around 6. The reason for this is to add a slight difference in the underlying texture. And then, with the directional warp, after warping, we combine it with our original horizontal strip. We can see that this is a multiplication. The original strip is multiplied by the result of our directional warp, and then a strength of 0.7 is given. This way, we can have a horizontal variation while also having a small ripple effect, right? In other words, you can see that this directional warp is only for creating the base of the horizontal ripple, right? It's essentially a tool-like node. The final output is still based on our horizontal base, creating this tool-like node, right? Now you can see what happens when I change the direction of the directional warp. If you go down, it goes left. If you go up, it goes right. You can play around with this node yourself. It will adjust according to a direction. For a more detailed explanation, you can refer to my previous videos. Okay, and then our E3, elements 3. Here we have a gradient linear 1. Why is it flowing here? We just need to rotate it. Rotate it 90 degrees and it will be the same. Then we give it a transform and I've shrunk it a little. We can change it to absolute and shrunk it a little. Hold down R, for example like this, and give it a transform. Sometimes shrinking might cause problems. Here's a simple demonstration. You can see that sometimes when you shrink it, there's no change, right? So we need to adjust the piling mode. This is what piling is. It's the piling mode. Do you want it to be continuous? If we change it to absolute, then we can see that this element is a single element, just like a layer in Photoshop. If we give it a horizontal continuous effect, it will have a continuous effect in the horizontal direction. If we give it a vertical continuous effect, then in the Y direction, it becomes seamless vertically, but not horizontally. Actually, we don't need that here, so we set it to low tiling mode. This is also low tiling mode. Let me explain for any newcomers who might not understand. Next is a levels node. Nothing much to say about that. We just use it to adjust the contrast. The time generator is also straightforward. We set it to 40 and minus 40. Then we apply an X and O scaling, right? X and O scaling, and then random scaling for X and O. For the Y-axis, we set the Y scaling intensity to 0, even though it originally had some scaling. It used to be a bunch of small floating strips like this, and after adding random size, random position, random rotation, random brightness, and random masking, it ends up looking like a bunch of meteor-like symbols, right? Symbols that look like meteors. This is also one of the elements we want to create. Here, we also add a Perlin noise. We use the same Perlin noise to apply a warp, and you can see that if you increase the value, it becomes even more distorted. Then we add a transform node, and by holding the shift key, we rotate it vertically, then merge it with our horizontal version. For the horizontal merge, we use a mask, specifically a check mask. We'll talk more about this mask later because there's a 14 node in between, so we'll come back to it. For now, just know that there's a merge here that separates the horizontal and vertical elements. Then we add a save transform node. Actually, it doesn't do anything, so let's just delete it. It doesn't do anything. Okay, so now we've finished making our small scratch and streak black and white mask. So we've covered 1, 1, 2, 3, 4. Now here, 14, actually this should be 15. Let me fix that for you. It's 15. There's a connection between 15 and 13. Let's take a look at what's going on with 15. First, didn't we just create a mask image here? Then we move it up one more point. 0, 1, 2, 5, right? And then over here, we merged it with our tile sampler. So what does the tile sampler do? Let me copy it out for you so you can take a look. The main thing the tile sampler does is create a 16 by 8 square, which is basically what we call square. How should I explain this to everyone? A square is basically a rectangle or a square shape. So what we're generating here isn't just pure white, but rather this kind of square shape. This thing is called a square, right? This is what we call a square. Then, over here, we've enabled a mask ratio, which basically means we've turned on what's called a mask. So what does a mask mean? It means that all of our parameters, like 8 and 16, our scaling parameter, our offset parameter, and our rotation parameter, right? All of these parameters are actually tied to, let's see, in the tile generator, the 8 and 16 are the same. The only difference is that it's made up of a bunch of little white squares. Let me turn the scale down a bit so it's easier for everyone to see. Now you should be able to see it clearly, right? Then, using a black and white shape image, like if I connect this shape to the mask input, the black and white shape image, and then use the mask threshold in this color node to control which areas show this element and which areas don't, right? You get that, right? This way, we can control, for example, if I set this to 1, set sky to 1, we get this jagged-shaped element. Okay, so basically, by using a mask plus a tile sample, we end up with a jagged-shaped mask. Then, this mask is multiplied with our original creation. You can see the difference before and after the multiplication. Before and after. Before and after. Basically, we've eliminated these two horizontal lines here. You can see that these two horizontal lines are gone, right? Then, over here, we did a rotation. Rotated it 180 degrees, right? Rotated it 180 degrees. Let me check. It's like this here. If you want it to do a mirrored rotation like this, there are generally a couple of ways to do it. The first way is to hold down the Control key and drag it like this to create a mirrored rotation. Another way is to open the Transform menu, go to Edit Matrix Value, and change our x2 to -1. Change it to -1, so it's 0, -1, 1, 2, something like that. This way, it will mirror along the x-axis. You can see, just hold down Control and drag. When you adjust this parameter, you'll notice that this number changes, right? So after you change it to a negative value, you can achieve a perfect mirrored flip. Of course, if you want, you can also use the mirror node, but you really need to pay attention to how this matrix works. As for what each of these parameters specifically means, I won't go into detail here. You can just hold down the Control key and stretch it to see how it changes. When you make some changes, you'll get a general idea of what these points mean. Try to focus on these four sides, the x-axis and y-axis, right? x2 and y1 control these specific points, right? As for the other points, some of them are left empty. For example, if you look at x1, it represents a skewed angle, right? A skewed angle, and that's also when we hold down the Alt key and skew it over, right? So x1 controls this area, and y1 controls, well, y obviously controls the bottom, right? It's a skewed angle. Then x1 and y1 control the angle for rotating, flipping, and scaling. Holding down the Control key gives you one angle, and holding down the Alt key gives you another. For now, just understand this much. Know how to flip and how to use Transform 2D to flip an image, and that's enough. As for what the specific parameters do, we'll talk about them when we get to them. Just remember this for now, okay? Now over here, we have a blend showing a subtraction. This is before subtraction, and then we use it to subtract. So what are we subtracting? We're subtracting these two rows in the middle, right? Subtracting the two rows in the middle. What does subtraction mean? It means we take the white pixels and subtract the black pixels, right? White pixels minus black pixels, using the white pixels from this layer and subtracting the layer below to get this result. So white pixels are 1, black pixels are 0. 1 minus 0 equals 1. 1 minus 1 equals 0. Doing the math like this gives us this effect. Okay, and here we have an image that is connected here as a mask. So where does this image come from? Let's go to the first combine node. How did this combine come about? First, it's our original. The previously generated jagged image is then fed into a very small precision warp. This small precision warp is connected via our E4 interface. This small precision warp is used for the first layer of combination, and its output is then given to us here. This image is then treated as a black and white image. The black areas represent our direction, and the white areas represent our direction. Therefore, it appears as alternating black and white, right? This mask is derived from here. Let's roughly summarize. Then here we get another warp. The input interface for this warp is the element we created earlier. Then here, we get a paranoia of 14. 14 gives us a warp, also very small, 0.03. This is also 0.03. Sometimes these two intensities are the same. Okay, then there's another small element I've marked separately. This is rotation. Rotation is what we're rotating. Since we created this element earlier, we need a direction for it, so hold down the Shift key and rotate it vertically. You can see that if it's horizontal, the position isn't quite right, right? The position is incorrect. Okay, so we just need to rotate it to a vertical position. Then I have a few adjustment nodes to explain. First, we need to adjust something, which should be called adjustment plus merge. I'll name it adjustment ratio plus and combine, right? Adjust plus merge ratio. Our first node is the copy. Because our vertical and horizontal axes are connected by our black and white nodes, we can get a graph like this, right? Then we give a 0.015 warp. Because the graph we created earlier has a tail, a warp is applied. What does warp mean? I won't go into too much detail. You can refer to my previous tutorials. Now, let's multiply our image, this large particle image, with the original, smaller one. You can see that some small textures appear on the large squares. Next, we adjust the level and color, slightly reducing the bright areas. Then, we add the element we created earlier to the element we just made. We add a very small amount, about 0.015. If we add 1, you can see small patterns like tadpoles. It would be too obvious. Those little fireworks would stand out too much. So we just add a tiny bit, and if you feel it's not enough, you can add a little more. Just a touch of difference, so both our base texture and the small scratches are present, right? This way, the details are richer. Okay, now we come to the third layer of combination. In this merging stage, we've added a few new nodes. One is adstrophy. No need to explain much. It's an anisotropic wave node. Here, you can adjust its quantity. Then, for transform, we slightly moved it outward and rotated it a bit. Since this layer needs to be combined with the previous layer of small ripples, this layer, the large ripples, they need to be stacked together. But I don't want their directions to be exactly the same, so we rotated it just a little bit, just a tiny bit. Now, let me introduce a new node called Make It Tile. Make It Tile, right? Photo grayscale. What does this mean? You can see that right now in this image, pay attention to the area in the red box. It looks like it's seamlessly tiled, right? But if I turn this off here, you can actually see there's a very obvious seam or transition, right? There's a clear seam or transition. So the Make and Tile node is used to eliminate those seams and transitions. The way it works is by taking, let me show you with this value. You'll see this mask set, right? It blurs the pixels in the middle and spreads them out to both sides. For this kind of linear, this method called linear four-way tiling is a pretty effective way to handle it. So here I used a make and tile parameter, something like this. You can download this file and take a look yourself, and you'll get it. Over here, I still use a save transform. There's really nothing much to say about these. Invert grayscale is also pretty straightforward, right? Then here, I added another transform. Here, I set the scale value. You can see here it's set to 2, which basically means we're multiplying the scale by 2, right? Divide by 2, divide by 2. Here it's 4, so if we multiply by 2, it's 2, right? Then, if we multiply by 2 again, it's 1. So it's basically the same as what we did earlier, right? We made it a bit smaller. Originally, it was this big. Now it's this small, just by multiplying or dividing by 2 to change it. It's the same here, just in a different direction. And here you can see which two are being merged. One is this one, and the other is this one, our original and the one that's been multiplied or divided by 2. After merging them, we can turn up the value a bit to see the difference. Basically, it performs an add sub operation. Add sub is something I introduced in my course, in my public class, the first time I showed everyone this kind of blend mode. Let me explain what add sub means. The Chinese translation is something like values greater than the foreground are subtracted from their respective backgrounds, and foreground pixels with values less than 0.5 are subtracted from their respective background pixels. You don't really need to worry about the Chinese explanation. Let me just tell you what it means. looking at this image, for example, this is the foreground and this is the background. If any pixel in the foreground is greater than 0.5, like these pixels, then it will be added to the background. So it's an add operation. If any pixel in the foreground is less than 0.5, like in this yellow area, then it will be subtracted from the background. So that's a subtract operation. For example, this part of the image will get brighter and this part will get darker, right? If you combine these two images, this area is subtracted. So that's the sub part. With this, you should be able to understand what add sub is and how it works. The overall effect is that it increases the contrast of our image, right? You can see that the contrast in this image is increased, but in reality, the operation is just a simple addition and subtraction. If it's less than 0.5, it subtracts that value. For example, if it's 0.3, then it subtracts 0.3 here, right? If it's 0.6, then it adds this 0.6 value. Now, let's try to understand this again. Program. If the pixel value is higher than 0.5, add it to the perspective background. In other words, if it's greater than 0.5, if our foreground is greater than 0.5, it will be added to our background. If the foreground's less than 0.5, it will be subtracted from our background. This is the same as what we just talked about. So sometimes you really need to understand how this calculation works. The theory and the text here aren't that important, okay? So the reason we're using add sub here is because we're basically taking our foreground and these things, these elements. Anything in there that's greater than 0.5 will be added to our background, and anything less than 0.5 will be subtracted from our background. So the result we get is definitely an image with higher contrast, right? You can see that, right? It's an image with higher contrast. So this kind of operation is also a contrast enhancement algorithm. And the area it controls is also determined by our foreground image. So here, everyone really needs to understand the logic behind this node operation, okay? Then after that, there's another add sub, but we won't worry about that for now. It's the same as before. Here, we also apply a transform. Did we change anything in the transform? We set its x2 to -1, which is basically like holding down the control key to mirror it. That's pretty much what it means, right? And then here, we use it again. Here, we're also using the mask from earlier. These two masks are both set to invert grayscale, which basically means we're reversing the black and white. Right? So in this way, we end up with two images, one facing up and one facing down, and then we do a save transform for both of them. But honestly, this save transform is pretty much useless. Let me take a look. This part is useless, this part is useless, and then we just merge them together using a simple overlay. I've already explained what overlay means earlier, right? So with this approach, the small textures are simply layered onto our final image. And then finally, we combine it with those little stripes we added at the very beginning. Right, we added the little stripes and this, what do you call it, spiky texture? And then we combine it with that. We layered it again with this thing, right? But you can see that the direction of this overlay is going this way, right? But our texture is like this, horizontal and vertical. Can y'all see the difference?